adjusting. Sorry for bad quality, but yeah, I don't have I cannot right now. I don't have the materials, but I just wanted to help you out something. So today I am. I decided to help people doing calculus, and before I start out with the whole lectures, I just wanted to start out with the main point views, so face outs. And this is the main is you have to understand that calculus is the study. It's a study of mathematics where you start studying rate. You probably have seen rate like this before. So let me see. Rate can be described as like a delta sign, or yeah. This is how you would describe rate mathematically. And the reason why I'm starting with this is because calculus is all about study of rate if you analyze it carefully. You see, like for example, uh, let's give an example related to physics. Acceleration is a vector, right? It's not scalar. It's the change of velocity over change in time. Yeah, time is not a vector, but yeah, change in velocity or change in time. And what you get by that is, yeah, you get acceleration is the change in velocity or change in time. And this describes a motion, usually. So if you have a velocity and a time graph, so let's say uh, velocity is here, time is here, what the acceleration is, is the slope, actually, of this line, which would be, this would be change in velocity over change in time. But recall, this is a vector, and this is not how you find a vector, but yes, this is how you find it. So basically, it's change in velocity over time. In calculus, what you say is, what happens if a time suddenly went straight zero? So we would use a notation called limits. The limit as delta t tended to zero, delta v over change in time. So this is another way, like, but this is called an instantaneous acceleration. So you basically don't have a nice velocity and a time graph. You have a function like this, a random function, and let's say the object's particle is here, and you have to find out what is this acceleration. Now, obviously, you probably might want to think about the right triangle from the delta v over delta t, but notice that this doesn't work in this case. Look, if we graph 2 points and another point here, the slope of this graph will change within seconds, and therefore, using the average acceleration formula will not be helpful. This is when calculus comes to help. In this section, which we'll learn in use of calculus in chapter 3, you'll learn about this. This is this is the case where we have to apply derivatives. So basically, the form of saying if time instantaneously went to zero, so if instantaneously went to zero, the velocity will be dv over dt. So in other words, it's saying that is the change of velocity over time. So yeah, probably might not be clear for you guys right now, but this is how you really get it. And an easier example is um, consider yeah, consider a wave. Consider a wave. Consider a wave. We know by physics that the angular frequency omega is equals to 2 pi f. 2 pi f 2 pi times frequency. But what if this wave is not periodic? By not periodic, we're not talking about sine or cosine curves. Remember, guys, that a wave function is has the initial formula of big X, x naught, cosine, omega t, or big X with x naught sine omega t, where omega is actually equal to this. But now, what if the wave is not periodic? What if the wave oscillates? This is another thing that you have to use calculus. And usually when we deal with waves, we use something called the Fourier series. And this is where you have to apply calculus. So, what is calculus? Well, I told you examples of calculus, but I never told you what calculus is. Like examples when you will use calculus, but I never told you what calculus is. So, calculus is the study of rate. So, it basically studies how fast something changes, how quick something changes, how slow something can change. And because of calculus, our world has a developed world. Our world is really developed in microscopic things. Like we know almost everything about microscopic things. And yeah, we can know like that right now, but that's actually not true. But yeah, that's really it. So my next lecture is of calculus. I'm gonna start off with limits. Limits is something interesting, and I will end up with Stokes' theorem, which is a multivariate calculus. And when we do Stokes' theorem, we might talk about electromagnetic flux. We might talk about many other interesting topics in the field of physics and mathematics. So I hope you got a grasp of what really calculus meant, and I just want you to remember that actually calculus is the study of change or rate of something. So I hope you enjoyed. Thank you.